Okay, in Objective 6 here, we are going to be writing equations, which means we're essentially going to be going the reverse direction of some of the things we've been practicing over the last several objectives. Rather than taking an equation and then moving it into a graph of some sort, we're going to be taking a graph and moving it back into an equation. And so we have up at the top here a reminder of the four function families that have formed kind of the basis of most of what we've been doing. We have our linear here with its descriptive form, our linear absolute value with its descriptive form, our quadratic, and our exponential, right? And then we have some general steps that we are going to be using or following here as we undo the process of our graph and create the equation from which the graph was formed. Okay? And so the general steps are, first, we want to determine the shape and write the equation. As I look at my graph, do I see a U shape? If so, I'm going to write the quadratic equation. Do I see an exponential? I'm going to write the exponential equation, so on and so forth. We want that kind of structure of our equation so that we can then identify the missing elements. The first missing element for most of our equations is going to be our HK, right? Our HK is one of the points on a line. Okay, and so I did want to include a little note here. For linear, any point works as HK. Which means for linear equations, we'll actually in some cases have multiple right answers. Let me zoom in on that a little bit, sorry. I wrote that a little small. There we go. For linear, any point works, let's put an S there, as HK. And so, yeah, for ones like number 1 that we're going to do here in a bit, there's potentially more than one right answer because any of your points works as HK. For a linear absolute value, though, or HK, remember, is our vertex here. Same thing for the quadratic. HK is the quadratic. And then for your points here, our HK, remember we always found our HK was on our exponential, and so we are going to be looking below one of our points for our HK on an exponential. We're looking at a point that's below one of the ones on the graph and sitting on an asymptote in order to identify our HK. Okay? After that, step 3, we're then going to either find or solve for the other elements of our graph. So that could be stretch or slope or the base or the leading coefficient, right? All these other pieces, the A in the quadratic, the A and the B in the exponential, the M's in the linear and the absolute values. And then step 4, put them all in their spot and create your final answer, right? Okay, so we're going to start here with 1, 2, and 3 because these are the types of problems that for the most part usually require the least amount of work. Okay, and so for each of these, I'm going to give you at different points a question. I'm going to encourage you to actually pause the video and answer the question, just like you would if you were in class, right? Where I would ask the question, I would pause and you would think for a second, write down a thought, and then maybe I'd have you talk to a partner or something like that. Unfortunately, it's a little hard to do that in distance learning, so I need you to own that. Pause the video, actually think about it yourself, jot a thought down, and then restart the video when you are ready, right? Okay, so for number 1 here, we're going to take a look at this. First thing we need to identify is, well, what is the shape and general equation or descriptive form equation for this function family? Okay, so what kind of function family are we working with? Okay, and that would be linear. And what is the descriptive form of the linear equation? Okay, the descriptive form is y minus k equals m times x minus h. All right, it's right here. Okay. Step 2, find your starting point, your HK. Remember that for a linear, any point works as HK. And so what would your HK be? Okay, well, your HK could actually be either one of these points, either 2, 3, or negative 1, 1. They both work. They would both be correct. Okay, for me, I'm going to use the point 2, 3 as my HK. And so then I'm going to plug them in, right? My K is 3. My H, sorry about that, is 2. right? Or you'd put in 1 and -1, right, into your HK. And then the last bit, step 3, is solve for everything else that's missing. And so in this case, this is my slope, okay? And you have two ways of finding slope. You've been finding slope, though, for years one particular way, and so that's my initial route that I'm going to take here. Finding slope, you've always done like rise over run, right? And so this one from point to point is rise of 2, run of 3. And is that a positive or a negative slope? Okay, that's a positive slope. So you have rise of 2, run of 3. Okay. Now there is another way for those who are like, oh man, slope, I always made mistakes there. The other option you have is you could take this equation you have, and so I'm going to borrow this space down here. Y minus 3 equals m times x minus 2. And you could take the point that you didn't use for HK, in this case -1, 1, and you could plug that in to your x and your y, right? -1, 1 was the other point. And if you solve then, 1 minus 3 is -2, -1 minus 2 is -3. And then dividing this -3 over, the negatives would cancel and give me a slope of 2/3, which is what I found by doing rise over run. Okay, and so both works, right? Okay, if there are questions on the linear, jot them down now. Okay? Number 2. Okay, go ahead and take a look at number 2. Remember, pause the video, actually answer the questions I'm posing for yourself. Okay? What kind of equation are we working with on number 2? Okay. Well, number 2 here is one of our special cases. It's a vertical line. And so if we are vertical, does that mean we are x equals or y equals? Okay. A vertical line, this is your function family review notes, a vertical line is an x equals line, right? A y equals is the horizontal. Okay? And so in this case, this is an x equals line. The question is, it's x equals what? And so as you look at that line, what does x equal? X equals -1. Okay? If there are questions, jot them down now. Okay, number 3, our function here. What type of function am I working with now? Okay, linear absolute value. What's the descriptive form of the linear absolute value? Okay. Y minus k equals m times the absolute value of x minus h. Okay, what is your HK for this one? What is your HK? Okay, remember HK on an absolute value is the vertex, so my HK is 3, 2. Okay, so let's go ahead and plug that in. Okay, and then last but not least, finding the rest of the pieces of this equation, which in this case is just the slope. Okay, what would my slope be for this absolute value? Okay. Well, this has a slope of rise 3, run 2, and is this a negative or a positive absolute value? Okay, that's a negative. So a negative, rise 3, run 2. Same thing as with the linear. You could solve for that -3/2 by taking the equation y minus 2 equals m times the absolute value of x minus 3. And using another point to solve for slope. In this case, maybe you use 1, -1. -1 minus 2 is -3. 1 minus 3 is -2. Absolute value of that is 2. And then dividing the 2 over, you get your slope of -3/2. And so you could always calculate the slope if you don't want to just count it. Okay, if there are questions on the linear absolute value, write them down below. Okay, quadratics. We're going to do 2 quadratics because these are ones that usually start to get a little bit trickier. Same thing as before. I'm going to highly encourage you to actually pause the video, answer the question on your own, start it when you're ready. Okay? So, first up, I already spoiled it slightly. This is a quadratic. What's the descriptive form equation for a quadratic? Okay, we have y minus k equals a times the quantity of x minus h squared. Okay? Step 2, what is my hk? Okay, well, hk for a quadratic is the vertex, so in this case, my vertex is 1, negative 1. Step 3, find the missing pieces. Now careful with quadratic, right? It's very tempting to want to treat a quadratic like slope, but remember what we said since the beginning. Quadratic doesn't have slope. It's an A, not an M. M is what we use to represent slope. This is an A, right? And so we can't do that. This is where solving is going to come in handy, okay? What is the other coordinate point I know on this quadratic? Or what is another coordinate I know on this quadratic? I know this one over here, right? At negative 1, negative 4. I'm actually going to use that coordinate point to solve for A. Okay, so my y is negative 4. My x is negative 1. Negative 4 plus 1 is negative 3. Negative 1 minus 1 is negative 2. Squared is 4. And so my A is, dividing that 4 over, negative 3/4. And I've got my equation. Y plus 1 equals my A of negative 3/4. X minus 1 quantity squared. Okay? Okay, for number 5, you have a choice here. You can either pause the video, work all the way through it on your own, and then double check your answer when you're ready. Or 2, you could kind of go along with me like I've been doing. I'm going to continue to ask questions. And you can pause the video with each of those questions and answer it as you go. But make sure in some way, shape, or form you are practicing this problem on your own. Okay? Okay, with number 5, first up, what's your function family? Okay, it's a quadratic. What's the descriptive form for a quadratic? Okay, we have y minus k equals a times x minus h squared. Okay, what's your hk? Okay, my hk is negative 4, negative 2. Let's go ahead and put that into our equation here. We want to find the a. Remember, a is not slope, right? M is slope. A is not slope, so we need to solve for A. What's another point I know on this quadratic that I can use to solve for A? Okay, well, I've got a point over here at negative 6, 0. And so let's go ahead and plug that in. 0 for y, negative 6 for x. 0 plus 2 is 2. Negative 6 plus 4 is negative 2. Squared is 4. Dividing that 4 over, my A is 1/2. And I've got what I need for my equation. Okay, if there are questions on the quadratic, write them down now. Okay, last one. We've got 3 of these. This exponential, just like it's usually the one that's the trickiest for people. to put onto a graph. It's usually the one that's a little bit trickier for people to pull off of a graph. There's a little bit more to solve for on this one. Okay, so I would highly recommend walking through one with me, then maybe walking through one a little bit more on your own, and then pausing the video and trying one completely on your own. But these are ones that you might need to build up to a little bit. Okay, we're going to go 6, 7, 8. Okay, number 6. So exponential, what's the descriptive form of an exponential? Okay, we have y minus my k equals a times b to the x minus h. Okay, finding your HK. Now careful about this, because a lot of people will want to look at the coordinate point and say that that's your HK, but think for a second. Where did my HK put me when I was graphing? What did my HK show me on a graph? It showed me my asymptote. In this one, my asymptote is here, right along the x-axis, right? So my HK isn't this coordinate. It's the point on the asymptote that is below that point. Okay, so my HK in this one is 0, 0. Okay. Okay, what makes the exponential usually a little bit trickier for people is we have two different variables, a and b. So this process up here of solving for a in my quadratic, I'm going to have to do that same thing down here for my exponential, but twice. First for a and then for b. And so we're going to end up using both of our points. So let's go ahead and start here with our 0, 1 and plug that into my equation. Okay, y equals 1. X equals 0. 1 minus 0 is 1. A times b to the 0. What is anything to the 0? Or I should say, what is b to the 0? It would be 1. And so we have 1, dividing that 1 over, 1 divided by 1 is 1. And so my a is 1. Okay, so let's go ahead and rewrite my equation now with the a plugged in. Okay, and then we do it again, this time to solve for b. My other coordinate point is out here at 3, 8. Okay, so y is 8, x is 3, 8 minus 0 is 8. Get 1 times b cubed. Dividing that 1 over, 8 divided by 1 is 8. And so what does that mean b equals? Some number cubed is 8. Okay, well, what number cubed is 8? 2 cubed is 8. And so we have our equation. Y minus my 0 equals 1 times 2 to the x minus 0. Okay, number 7. So I would encourage you, work through it a little bit more on your own now. Let's go ahead and work through number 7. Okay, we have an exponential. What is my descriptive form then? Well, my descriptive form would be y minus k equals a times b to the x minus h. Okay, so what is my HK? Remember, HK is on the asymptote below one of your points, so there's my HK. And that is at 2, 1. Okay. Okay, and then using my two other points to solve for a and b, let's go ahead and start with the point 2, 2. Plug it in. 2 into my y, 2 into my x. 2 minus 1 is 1. A times b to the 0, which is 1. Dividing that 1 over, my a is 1. Okay, so let's go ahead and rewrite our equation with a as 1. Okay, then take your other point and plug it in. My other point is at 0, 5. Up here. Plug it in. Okay, 5 minus 1 is 4. Dividing that 1 over, we get 4 equals b to the negative second. So what does that mean b equals? Okay, this is one that sometimes is a little bit trickier for people. So if it's helpful, ignore the negative for a bit and go b squared is 4. What if b squared was 4, what does that mean b would be? So we're talking 2, right? So b squared, if b squared equals 4, it'd be 2. Now what does a negative do again? A negative flips your fraction, right? So if this was b squared equals 4, my answer would be 2. What do you think then that b to the negative squared would be? Well, it would flip that 2 and become 1/2. So you have your equation, y minus 1 equals my a times my b to the x minus 2. Okay? Okay, number 8, your choice. Go ahead and either pause the video and try it on your own, or walk along with me, pausing the video with each step and trying it on your own. But in some way, shape, or form, do this problem somehow on your own. Okay? We've got an exponential. It's descriptive form. What then would be my HK? Okay, on the asymptote, below a point, right? So we have an HK of 1, negative 1. Okay, then go ahead and take a moment, use 1 point to solve for A. So use our 1 and our half here to solve for A. 1/2 plus 1 is either 1.5 or 3/2, whichever one you prefer. B to the 0 is 1. So my A is 3/2 or 1.5. Rewriting my equation. And then you're going to use your other point to solve for B. My other point is 2, 5. Okay, 5 plus 1 is 6. This is B to the first, which is just B. And then dividing that 3/2 over, what does it mean to divide by a fraction again? Okay, dividing by the fraction is the same thing as multiplying by its reciprocal, so multiplying by 2/3. Let me go ahead and put that in a different color here. All right, so timesing by 2/3 would cancel. So we'll times by 2/3 over here. So these cancel then. We get B equals 2 times 6 is 12, divided by 3 is 4. And I've got my equation. Okay, if there are questions on the exponentials, write them down now. Okay, our last two problems are going to be piecewise. And I always save these for last because the nice thing about piecewise is it's made up of all of the other equations we've already been looking at, right? The only thing that is going to change about a piecewise equation compared to the others is going to be that restricted domain, right? We're going to need to identify, well, on what regions is this element of my piecewise actually showing, right? So we're going to walk through number 9 together. Again, same encouragement. Actually try to answer the question on your own, and then restart the video as you're ready. Okay, number 1, we're going to determine the type of function represented with each leg of the piecewise function. After we do that, step 2, we're going to identify what is the restricted domain for that leg. On what values of x do I actually see that function occurring? And then the last step is we're going to write the equations, right? And so we see that modeled here in number 9. First, we need to identify what functions am I even looking at. Okay, so let's go ahead and take a look at negative infinity to 0. What function am I looking at from negative infinity to 0 here? What type of function is that? Okay, that's a linear. And then I'm going to go ahead and add in to help us with our piecewise function. What then would my restricted domain look like? Maybe take a look back at 1.3 when we were looking at graphing piecewise. Okay? How did we write in our equation my restricted domain? Okay, we wrote in our piecewise equation, our restricted domain was given in some form like this, right? Or maybe it just said the x is less than 0, right? Either one is technically accepted. I'm going to be writing this one because that's, I'd say, more common. Why do we not have equals on any of these inequalities? Well, because we can't equal negative infinity, right? It's not possible. And for my linear, look what happens at x equals 0 for this linear. There's a hole, right? If that hole was filled in, then I'd be putting in equals. But that's not the case for this one, right? So I'm just going to do a less than. Okay, what about the next interval, 0 to 6? What kind of function do I have there? Okay, well, that's a quadratic. And how would I write its restricted domain? Okay, well, this one starts at 0 and goes to 6. So we're going to be starting at 0 and going to 6. And then are we doing equals on the 0? Are we doing equals on the 6 or not? Okay, we'll take a look at 0 on the quadratic. Is there a point? Yes, there is, so that's an equals. What about on the 6? Yes, there is, and so that's an equals. Okay? And so last step, we're going to write our piecewise defined function, one for the linear, one for the quadratic. So let's go ahead and set this up. We're writing it for f, so we're going to write f of x equals, and you're going to want to give room for two functions. First, the linear, which is going to be when either this one or this one. So I'm going to write just x is less than 0. Right? And then one for the quadratic, which is this guy here. Okay, so this is going to be my piecewise function. Okay, so let's find these two equations. Linear first. Okay, for a linear graph, what's my descriptive form? Okay, my descriptive form is y minus k equals m times x minus h. Okay, what's my hk for this line? Okay, remember for a linear, any hk works, any point works. And so I'm going to go ahead and use this point here at -1, -2. Okay, you also could use this point here if you wanted to at -3, -1. Right? Okay, what's your slope? Okay, well, this is a negative slope. It's down 1 over 2. It's a negative slope, down 1 over 2. Okay, and then to put this into this equation, notice this says f of x equals or y equals. It doesn't say y plus 2. So I'm going to go ahead and subtract this 2 over to the other side, so that now it matches my function here, right? Y equals for both of them. And I'm just going to slot this into my linear. Negative 1/2 x plus 1 minus 2. Okay, quadratic's up next. What's the descriptive form for a quadratic? Okay, we have y minus k equals a times x minus h squared. Okay, what is my hk for this quadratic? Okay, my hk is at 2, negative 3. Okay, now we need to solve for a, and so you can use either point. Okay, I'm going to use 0, negative 1 myself, just because those are smaller numbers. And then go ahead and solve for a. Whoops, I forgot to put my h in, sorry. H is 2. Okay, negative 1 plus 3 is 2. 0 minus 2 is negative 2. Squared is 4. And dividing that 4 over, we get 1/2. So my equation is y plus 3 equals 1/2 times x minus 2 squared. Same thing, notice that this says f of x equals or y equals, not y plus 3 equals. And so I'm going to go ahead and subtract that 3 over so that it matches. Slot that into your quadratic. Okay. Okay, number 10, last one. And again, write down questions if there are questions. Write them down now so you don't forget. Okay, first up, A, for the interval negative infinity to 0, what type of function are we looking at there from negative infinity to 0? Okay, from negative infinity to 0, that is a quadratic. And it does say write the equation of the function. I'm going to come back and do that real quickly here. How would I write my restricted domain for this quadratic? Okay, well, it goes from negative infinity, remember, which will never be equals. Negative infinity and infinity will never be equals, all the way to 0. Is there an equals on 0? No, because that's a whole, right? And so you can either write it like this or like this, either one. Okay? B, for 0 to 2, what type of function is represented? Okay, well, from 0 to 2, that's a linear. How would I write its restricted domain? Okay. Its restricted domain would be 0 to 2. Okay? Equals or not on 0? Okay, well, that's a whole, so no equals. What about at 2? Okay, well, at 2, there's a point, and so there would be an equals here. Okay, we'll come back to the equation for this one as well. C, though, I want to answer this one first before we start doing our equations. 2 to infinity. What type of function do we have? Okay, well, that's an absolute value. How would you write its restricted domain? Okay, well, it goes from 2 to infinity. Is there an equals on 2? Yeah, there's a point. How about on infinity? No, remember, never a point on infinity or negative infinity. Okay, let's go ahead and make these equations. Let's come back to our quadratic. What is the descriptive form for our quadratic here? Okay, this would be y minus k equals a times x minus h quantity squared. What's your hk? Okay, my hk would be down here at -2, -3. Okay, use another point now to solve for your a. I'm going to use the point 0, 1. Okay, 1 plus 3 is 4. 0 plus 2 is 2. Squared is 4. Dividing that 4 over, get a is 1. And then remember our piecewise, we want this to say y equals, so let's go ahead and subtract that 3 to the other side. Okay? Okay, linear's up next. What's your descriptive form for linear? Okay, well this linear here is a horizontal, right? So that would be a y equals. In this case, it would be a y equals what? Okay, this line here is at y equals 1. Right? The special cases. Horizontal line is a y equals line. Vertical is x equals. Okay, absolute value's up next. What's the descriptive form for the absolute value? We have y minus k equals m times the absolute value of x minus h. Okay, what's my hk for this absolute value? Okay, the hk is 4, 0. Okay, and what's your slope? Okay. Well, the slope is rise of 1, run of 2. Is this a positive or a negative absolute value? Okay, it's a positive, right? Facing upwards. So rise of 1, run of 2. Okay, so we've got our 3 equations here. We get to part D, and wait just a minute. It says write a 4-pieced, piecewise defined function. And you might initially go, what? I've got my quadratic, right? I can write that one. 1 times x plus 2 quantity squared minus 3 with its restricted domain. Remember, either one of these works. I could write my linear, y equals 1 with its restricted domain. I could write my absolute value, 1/2 absolute value of x minus 4 with its restricted domain. This one also, by the way, could just be greater than or equal to 2 if you didn't want to go all the way to infinity. Or you could write it as to infinity. That's fine as well, right? If you'd prefer to write it like this, you can. So what then is the 4th piece? Okay, we'll take a hard look at that graph. We've described everything on that graph except for one piece of it. What piece did we never point at or talk about or anything like that? Okay, it's this point right here. I like ending with this one every year because it's a good chance for us to take a look at what do we do when there is just this random point. It's not part of a function, right? As far as I know, it's not part of a linear or a quadratic. I mean, you could come up with a random line equation if you wanted to that goes through 3. Okay? Or you could just say, and I've got a point. at y equals 3. And what would be the restricted domain for that y equals 3? AKA, a different way of saying it, what are the x values that exist when y equals 3 at this point here? What x values exist for that point? Just one, right? That one is when x equals 0. It's kind of a funny element of a piecewise function. It's how we get a single point, is when we have a value at an x equals, right? You could write this as a coordinate point. When x equals 0, y equals 3, and it gives you a single point on a graph. Okay? If there are questions, write them down now.